Hello student, today we are going to discuss about a refractive index. In previous class, we discussed about a new part, new nature, that is refraction. And the next topic actually in refraction is law of refraction. But before study the law of refraction, we should understand about the refractive index. Actually, first thing, what is refractive index, how many is time, what is its value, and how it plays an important role in refraction. Actually, refractive index is an ability. Actually, you know that refraction tells when light passes from one medium to another, then the ray of light bends either towards the normal or away from the normal. It is just depends upon the density of the medium, and we discussed in the previous video about the density. So actually, when light passes from one medium to another, that means if light passes from rarer to denser or denser to rarer, then it bends. But how much the light bends when it emerges in the next medium after refraction, it just depends upon the ability, strength of that medium. Every medium have its particular strength to bend its light with a particular angle. Suppose that we have experimentally, imagine we have three medium and light refract in these medium from air. That means first is air to water, second one is air to glass, and third one is air to oil. That means we can say that in these cases, light passes from rarer to denser. Either air to water, it is rarer to denser, either glass, it is rarer to denser, and either oil, it is rarer to denser. But every denser medium have its own density. Water have different density, oil have different, and glass have different. So if the angle of incidence in air is equal in all these experiments, then after refraction, the angle of refraction in all the denser mediums will not same. Why? Because their densities are different. So they bend the light when passes through it, have a different angle. So every medium have a capability to bend the light when passes through it. That capability is known as refractive index. So actually, normally we define refractive index that the ability of the medium to bend the light when it passes through it is known as refractive index. But mathematically it is just a different. Now let's see on the board. Actually, refractive index is denoted by the letter mu or n. Actually, mu is the specific denotation of refractive index. So we know that refractive index is the ability, actually it is just an ability, strength of a medium to bending the light when passes through it. ये वो स्ट्रेंथ है किसी मीडियम का जो अपने से पास होने वाले लाइट को किसी स्पेसिफिक एंगल से मोड़ता है. But mathematically, refractive index of a medium is defined as the ratio of the speed of light in air to the speed of light in that particular medium. So we can say that refractive index of a medium is equal to the ratio of, actually refractive index also a tensor quantity. Like vector, scalar and tensor, so refractive index is a tensor. Those quantities are called tensor quantity, which is neither a vector nor a scalar, only the ratio of same physical quantity. So here refractive index is the ratio of same physical quantity, that is speed by speed. So it is a unitless quantity, it is a dimensionless quantity, it has no any unit. So mathematically refractive index of any medium is defined as the ratio of the speed of light in air to the speed of light in that particular medium. So we can say that speed of light is constant. Actually it is equal to 3 into 10 to the power 8 meter per second. Hence we can say that refractive index of any medium is inversely proportional to the speed of light in that particular medium. Actually refractive index have two parts, two types. First is called absolute refractive index and second one is relative refractive index. So when a refractive index of any medium, that is the case, refractive index of any medium when considered with respect to air, then that is called absolute refractive index. So when a refractive index of a medium is considered as air, that means when light passes from air to any of the denser medium, any medium, but the first medium is air, that means light incident through air medium and refract in any other, then that refractive index is known as absolute refractive index. And absolute refractive index is equal to the ratio of the speed of light in air to the speed of light in that particular medium. But when the refractive index of any medium is considered with respect to any other, so let's see, then that is called relative refractive index. Suppose that we have two medium, first and second. This is our separating line, that is XY transparent line which separate two medium. The first medium having refractive index mu1 absolute, that is the absolute refractive index, and the second medium having refractive index mu2, this is also the absolute refractive index. Mn is a normal at point O. Now if mu2 is greater than mu1, that means if the refractive index have a greater value, then that medium is denser, and refractive index has a lesser value with respect to, then that medium is rarer. So here mu2 is greater than mu1, that means we can say medium 2 is a denser with respect to medium 1, and light passes from this to, so it moves towards the normal, that is AOB. Here I and that one R. Here I, that one R. So when light passes from one medium to another, then if we consider the refractive index of second medium with respect to first, then we can write mu21. That means mu21 or mu21. और इसको पढ़ेंगे कैसे? That means the refractive index of second medium with respect to 1, or refractive index of second medium with respect to 1. This is called relative refractive index. Actually, relative refractive index, we discussed just relative refractive index mu21. Actually, it is the ratio of the two refractive index, absolute refractive indexes. That means if it tells that refractive index of second medium with respect to 1, then we can write refractive index of second, that is the absolute, by refractive index of 1, that means with respect to air, that is the value. So refractive index of second medium with respect to first is written as mu2, that is absolute refractive index of second medium, by the absolute refractive index of first medium. Or we can say 2,1 is equal to, we can say that this is written as C by C2 by C by C1. We can say CC cancel. Therefore, mu21 is equal to C1 by C2. That is the refractive index of second medium with respect to first medium, is the ratio of the speed of light in first medium to the speed of light in second medium. In next class, we will discuss about the theory of reversibility and something more about refractive index. Right? So please see this video carefully, because it is a very important thing for refraction. For today, thank you.